The current state of large language models, LLMs, has led to significant improvements in understanding and generating complex mathematical content. However, the availability of high-quality, varied, and difficult mathematical questions is dwindling. To address this issue, a design framework is proposed that combines the strengths of LLMs with a human-in-the-loop approach to generate a diverse array of challenging math questions. The framework leverages LLM metacognition skills to extract core skills from existing math datasets, which serve as the basis for generating novel and difficult questions. The use of two very different skills within each question makes finding such questions an out-of-distribution task for both LLMs and humans. The pipeline employs LLMs to iteratively generate and refine questions and solutions through multiturn prompting, with human annotators verifying and further refining the questions. The proposed framework is applied to the math dataset, resulting in the creation of MATH2, a dataset of higher quality math questions. The performance of all models on Math2 is lower compared to Math, indicating the increased difficulty of the questions. Additionally, using Math2 questions as in-context examples leads to higher performance on Math. A striking relationship is observed between models' performance on the new dataset, with the success rate on Math2 being the square of the success rate on Math. The evaluation saturation phenomenon is also discussed, where LLM evaluations become saturated due to across-the-board improvements and evaluation-specific enhancements. The distinction between general and evaluation-specific improvements is crucial, as the latter may lead to overfitting to particular evaluations rather than a genuine acquisition of mathematical skills. The proposed framework aims to address this issue by generating novel and difficult questions that require a non-trivial combination of two distinct math skills. The AI-assisted question generation pipeline involves a 5-step process: skill pair validation, question generation, attempted solution, question validation, and final solution. This pipeline leverages human expertise and large language models, LLMs, to generate high-quality, novel questions that combine distinct mathematical skills. The process begins with skill extraction, where mathematical skills are identified and cataloged from a dataset. The pipeline then generates questions that combine pairs of distinct skills, increasing their difficulty and requiring out-of-distribution thinking. The use of random pairs of skills is crucial for improving diversity and difficulty among generated questions. This approach necessitates the application of two distinct underlying skills, making the questions more challenging for both LLMs and human raters. The generated dataset, MATH2, is significantly harder than the existing math dataset, with a success rate of 0.25 for models that achieve a 0.5 success rate on Math. The pipeline's performance is evaluated using various open-source and proprietary models, including GPT-4, Claude, and MetaMath. The results show that models demonstrate lower performance on Math2 compared to Math, with proprietary models exhibiting smaller performance drops. The paper also discusses the importance of human-AI collaboration in generating novel evaluations and the potential for introducing fresh perspectives into math instruction. The pipeline's design methodology and generation process are detailed in Section 2, while Section 3 discusses the performance of various models on Math and MATH2. Section 3.2 explores the relationship between Math and Math2 scores, and Section 3.3 demonstrates the usefulness of Math2 questions as in-context exemplars for LLMs. Section 4 sheds light on the interesting behaviors and failure modes of leading LLMs observed during the question generation process. The pipeline's structured approach to generating challenging mathematics questions combines the strengths of LLMs and human expertise, ensuring a comprehensive evaluation framework. The use of advanced techniques like in-context exemplars and self-consistency ensures the accuracy and quality of the solutions, maintaining the integrity and reliability of the generated questions and their solutions. The proposed approach generates difficult math questions using a 5-step process, commencing with skill pair validation to ensure qualitative similarity and exclude similar skills. The model then generates a question and brief solution, followed by an attempt to solve the question, identifying potential flaws. The generated question and solution are validated against a fixed rubric consisting of 7 criteria, using reference examples and validation exemplars. For valid questions, the model resolves the question to obtain a final solution, with reference examples provided in context to improve understanding. The generated questions are further screened by humans, combining the strengths of AI and human oversight. The Math2 dataset, generated using this pipeline, is demonstrated to be more challenging than the original math dataset, with models exhibiting a significant drop in accuracy when tested on MATH2. The performance of various machine learning models on Math2 is compared to their performance on Math, revealing a linear relationship between the two, with a predictable relative drop in performance. The generated questions are also evaluated as in-context exemplars for the Math dataset, outperforming two baselines. The effectiveness of these questions is attributed to their difficulty and skill relevance. The importance of human raters in improving generated questions is highlighted, as models may fail to create interesting and creative questions. Limitations of the approach include the need for larger datasets generated using the proposed pipeline to reduce reliance on external exemplars. The research presents a novel approach to generating math questions requiring multiple skills and demonstrates their effectiveness as in-context exemplars. The evaluation results show that the Math2 dataset is more challenging than Math, with models demonstrating a significant drop in accuracy. The linear relationship between the performance of models on Math2 and Math implies that the relative drop in performance is predictable. The generated questions serve as effective in-context exemplars, outperforming baselines, and highlighting the importance of human raters in improving generated questions. The proposed framework combines human and AI capabilities to generate novel, challenging mathematics questions. Large language models, LLMs, extract and name key skills necessary for solving math problems, while human annotators refine and improve the generated questions. The framework's performance is evaluated on the math dataset, with results showing that few-shot prompting with exemplars retrieved from the generated set of questions, Math2, outperforms vanilla few-shot prompting, achieving gains of up to 3.75%. The four-shot COT prompting strategy, which involves retrieving exemplars from MATH2, achieves the best performance. The framework enables the creation of creative and challenging questions through human-AI interaction, with human annotators verifying the validity and correctness of the questions. However, the framework is not without limitations, including failure modes such as insufficient involvement of skills, insufficient information, and nonsensical questions. These limitations highlight the essential role of human oversight in refining and improving the generated questions. A pipeline is developed to generate questions combining pairs of skills, leveraging named skills from the math dataset and multiturn interactions with advanced LLMs. The proposed pipeline produces questions with greater novelty and difficulty compared to those in the original math dataset. The performance of leading models, including GPT-4t and GPT-4o, is evaluated on the new questions, with results showing that providing the newly generated questions as in-context examples improves performance. The authors plan to release detailed information about their pipeline to encourage further research and development in the field of open-source math models. Limitations in future work include optimizing prompting strategies, reducing human verification through automated validation tools, and enhancing the pipeline with a training-based feedback loop. The potential application of the proposed framework to efficiently produce high-quality data in domains beyond mathematics is also discussed. The development of a new AI model, Gemma, is presented, which is designed to be more efficient and effective than existing models. A new dataset, Open Math Instruct 1, containing 1.8 million math instruction tuning data points, is introduced for training and fine-tuning AI models to improve their performance in solving mathematical problems. A novel approach to solving geometry problems without human demonstrations is also presented, using a model called Solving Olympiad Geometry, which achieves high accuracy in solving complex geometry problems. The use of chain-of-thought prompting is discussed, which involves providing the model with a series of questions that require step-by-step reasoning to solve, significantly improving the model's ability to generate accurate and logical responses. A new evaluation framework, SkillMix, is introduced to assess the model's ability to combine multiple skills in solving complex problems. A new model, MetaMath, is also presented, which can generate mathematical questions based on given skills and can be used as a tool for creating customized math exams. The challenges of evaluating the reasoning abilities of large language models through question generation and validation are discussed. The authors highlight the importance of filtering out questions that require brute force calculations and introduce an explicit condition to check for computational tractability and solvability of generated questions. A sophisticated validation prompt is developed to address issues such as nonsensical questions, deceitful solutions, and the lost in the middle challenge. The authors provide an example of a question that requires the application of two distinct mathematical skills and demonstrate the model's reasoning trace, highlighting the importance of carefully designing the validation prompt to ensure that the model is evaluating the correct skills. The approach involves replacing referential terms with skill names to nearly eliminate the problem of the model confusing the pair of skills at hand. The development of a system utilizing large language models, LLMs, to generate math problems and solutions is presented, aiming to mimic a math teacher's thought process and test students' reasoning and analytical skills. However, failure modes such as generating overly difficult or easy questions, or those requiring brute force computation, are identified. To address these issues, a validation step is introduced, evaluating generated questions for syntax, grammar, and mathematical reasoning. Human verification is still necessary to eliminate potential failure modes. The authors observe instances of creative behavior in the models, such as considering computational tractability, attributed to the role-playing nature of the prompts. Human annotators are tasked with verifying the validity of generated questions and solutions, improving readability, quality, and difficulty, and suggesting changes to make problems harder for automated tools while retaining human solvability. A comparative analysis of model performances on generated data versus math reveals a quadratic relation between the two. Smaller models generally show larger degradation in performance compared to larger models, except for the Gemma family. This finding aligns with conclusions on compositional generalization, suggesting larger models are better at composing skills or concepts. The generated dataset consists of 180 questions, each representing 2 skills, with a total of 97 skills out of 114 extracted skills. The distribution of skills is not uniform, with multiple skills represented by only one question. The skill composition using different models is evaluated, demonstrating their ability to generate questions testing multiple skills, such as area calculation and algebraic manipulation. The generated question involves finding the value of k, requiring algebraic manipulation and area calculation skills, showcasing the composition of skills in the generated dataset. The provided pages present 3 mathematical problems that test area calculation skills and algebraic manipulation skills. The first problem involves finding the area of a shaded region consisting of an equilateral triangle and 3 squares constructed externally on its sides. The solution requires calculating the areas of the equilateral triangle and the squares, as well as algebraically manipulating the expressions for side lengths and areas. The problem is calibrated to be similar in difficulty to provided examples, and the solution is a single numerical constant k. The second problem involves finding the area of a smaller circle inscribed in an equilateral triangle and externally tangent to a larger circle. The solution requires using the Pythagorean theorem and solving a quadratic equation with radicals to find the radius of the smaller circle. The area of the smaller circle is then calculated using the formula for the area of a circle. The third problem involves finding the area of a shaded region consisting of a square inscribed in a circle and a semicircle drawn inside the square. The solution requires calculating the area of the square and the area of the semicircle, and then subtracting the area of the semicircle from the area of the square. The pages 23 and 24 of the research paper discuss the development of a system for generating math questions that test both algebraic manipulation skills and area calculation skills. The authors provide examples of questions and their solutions, as well as prompts for validating skill pairs and generating new questions. They also detail the prompts used in various stages of question generation and evaluation, including skill pair validation and question generation. Overall, the problems and solutions presented on these pages provide a comprehensive and challenging assessment of mathematical skills. The evaluation of mathematical reasoning abilities in students necessitates high-quality questions that assess expertise in multiple skills simultaneously. Two skills, Skill 1 and Skill 2, are considered, with example question-answer pairs provided to facilitate understanding. A question is presented, along with an attempted solution, to be validated based on several criteria, including the single answer requirement, exact answer requirement, dual skill requirement, clarity and completeness, computational tractability, relevancy of information, realism and logic, and syntax and grammar. The validation process involves reviewing the question and attempted solution, paying attention to how well they align with the example question-answer pairs for each skill. The complexity and difficulty of applying both skills in the question should be similar to or greater than the complexity and difficulty in the example question answers. The solution should not make any assumptions or approximations not explicitly stated in the question. A comprehensive analysis of Skill 1 and Skill 2 is presented, with sample questions and solutions, as well as a new question that requires the application of both skills to solve it. The authors provide a detailed prompt for the final solution, emphasizing the use of in-context exemplars from Math, Hendrycks et al., 2021. The evaluation section outlines a prompt for evaluating the model solution, tasking a professional math teacher with assessing student performance on a math exam. The evaluation process involves a step-by-step explanation of the thought process followed by a yes or no answer indicating the correctness of the student's solution. The authors encourage the use of prior knowledge and understanding of the skills beyond the sample questions provided. The validation process is challenging, and sample conversations between an AI agent and a teacher are provided to illustrate potential difficulties.